Welcome to Saucy Math. Today I'm going to talk about the laws of exponents. So I'm going to go through just kind of what exponents mean and some of the rules for exponents, and then just do a few examples that involve simplifying exponents using these laws of exponents. All right, so first of all, just like some basics about exponents. Basically what an exponent means is repeated multiplication. So I wrote here, 2 to the negative third, 2 to the negative 2, all the way up to 2 to the positive third power. So just kind of see the pattern of how this works. I'll start with the positive exponents because those are the easiest ones to understand. 2 to the first power is just 2. Right? Anything raised to the first power is just itself. Right? 2 to the second power means that base number 2 multiplied by itself 2 times. So 2 times 2 gives us 4. Right? 2 to the third power means the base number 2 multiplied by itself 3 times. Right? So 2 times 2 is 4, times 2 again gives us 8. Right? So this one was 2 times 2, this one was 2 times 2 times 2. Right? So it's the base number multiplied whatever the exponent is, that's how many times you multiply that number. Right, so that's the meaning of a positive exponent. Now to figure out the zero exponent and the negative exponents, it gets a little trickier, but if you understand the pattern of how it all works, it really makes a lot of sense. All right, if you look at these numbers here, if you go from left to right, to get from one number to the next, you're always multiplying by 2. Right? 2 times 2 is 4, 4 times 2 is 8, 8 times 2, the next number is going to be 16, the next one after that would be 16 times 2, which is 32, and so on. But if you move from the right to the left, you're dividing by 2. Right? 8 divided by 2 is 4, 4 divided by 2 is 2, 2 divided by 2 is 1. Right? So 2 to the 0 power equals 1. It has to in order for it to fit the pattern of, when you're moving from the right to the left, you're dividing by 2 each time. Right? And really anything raised to the 0 power is always going to equal 1. And then if we keep moving to the left to get to 2 to the negative 1 power, well, we do the same thing, right? When we move to the left, we divide by 2. 1 divided by 2 is 1/2, right? Which is 1 over 2 to the first power. Right? Let's go to the next one. If we do 1/2 divided by 2, we're going to end up with 1/4, right? Which is 1 over 2 to the second power. If we keep going to the left, we do 1/4 divided by 2, we're going to get 1/8, right? Which is 1 over 2 to the third power. All right, so the negative exponents, really what they are reciprocals, right? Remember, reciprocal means you flip over a fraction. So 2 to the negative third power is 1 over 2 to the positive 3 power, which is 1/8. Right? 2 to the negative 2 power is 1 over 2 to the positive 2, which is 1/4. Right? And it's always that pattern. If you move from left to right, you multiply by 2 to get the next number. All right, so when you have these negative exponents, you end up with fractions. Positive exponents give you those whole numbers. Right, so if you remember that pattern, it's kind of easy to remember what to do with that 2 to the 0 power or anything to a negative power. And if you change the base to a 3 or a 5 or whatever else you want to change it to, you're going to see the same pattern. If you change it to 3 raised to powers, it's just going to be when you move from left to right, you multiply by 3 each time instead of here we're multiplying by 2. Right, but it's the same pattern and the same things are going to happen. All right, so let's do some examples of kind of working with the rules or the laws of exponents and then simplifying expressions that involve exponents. So first of all, I've seen in the past students have confusion about what it actually means to simplify one of these expressions. There's basically 3 things that you need to make sure of when you're trying to simplify one of these exponential expressions. First, you want to have just one of each base. Right, so you see here, if we have x to the third power times x squared, we don't want those 2 bases of x. We want to combine those together so there's just a single x there. Then we want to have no parentheses involved. And then also we want to make sure we have no negative exponents left in our expression. Right, so those are the 3 things we need to make sure happen when we're simplifying these expressions. Right, so the first one, x to the third power times x to the second power. Right, so when we're multiplying exponential expressions that have the same base, right, they're both base x, we add the exponents. So it's going to be x raised to the 3 plus 2 power, which is going to be x to the 5th power. All right, so when it's the same base being multiplied, you add the exponents, and 3 plus 2 gives us 5, so it's x to the 5th. Now the reason that is, x to the third power is x times x times x. All right, that's 3 x's multiplied together. And we're multiplying that by x squared, which is 2 x's multiplied together. All right, so all together we have 5 x's being multiplied, that's x to the 5th power. All right, so that's the reason there that we add those exponents. All right, for the next example we have here, b to the 5th power divided by b squared. All right, so the rule when we're dividing exponential expressions that have the same base is that we subtract the exponents. Right, so it's going to be b, and we always take the top one minus the bottom one, right? The top exponent minus the bottom exponent. So it's going to be b to the 5 minus 2 power, which is going to leave us with b to the 3rd power. Right, now we only have one base b, there's no parentheses, there's no negative exponents, so we've simplified this expression. Right, and the reason this is the rule, if you go back to the original, b to the 5th power means 5 b's being multiplied together, divided by b squared, or b to the 2nd power, which is 2 b's being multiplied together. Right, those 2 b's at the bottom cancel out 2 of the ones that are on the top, and we're left with 3 b's multiplied at the top, which is b to the 3rd power. All right, so that's why when we are dividing, we have to subtract those exponents, because those ones on the bottom are going to cancel out the ones at the top. All right, so we subtract those away. The next example, we've got c to the 3rd power raised to the 4th power. All right, so sometimes this is called a power to a power. All right, so c to the 3rd power raised to the 4th power, the rule for that, or the law of exponents for that, is when you have a power raised to another power, you multiply those two exponents together. So 3 times 4 is going to give us c to the 12th power. Right, and we had to do that because this original expression here had parentheses, and when we want to simplify an exponential expression, we don't want any parentheses left in our answer. Right, so we had to combine that 3 and 4 by multiplying. Right, and the reason that one works as it is, or the reason that rule is what it is c to the 3rd power to the 4th power means we're going to have c to the 3rd power multiplied 4 times. Right? It's taking this thing in parentheses and multiplying it by itself 4 times. So c to the 3rd times c to the 3rd times c to the 3rd times c to the 3rd. And then that's kind of like that first rule we talked about. They're all the same base being multiplied, so you add all the exponents. 3 plus 3 plus 3 plus 3. Well, that's 3 times 4, which is 12. Right? So the shortcut to that is just take 3 and 4 and multiply them together and you get 12. But the thing about these rules of exponents for either of these first 3 we talked about, if you forget what the rule is or what that law says to do, if you kind of work it out like we did on the side here, you can always figure it out for yourself. Right? It's never impossible to figure out. It's just a lot quicker if you remember the rule, when you multiply, you add the exponents. It saves you a little bit of time to figure these things out. All right, the next example, we've got 5x in parentheses raised to the 2nd power. Right, so when we have a parenthesis like this raised to the 2nd power, basically what that means is, or the law for exponents for this is almost like you're distributing that exponent into the parentheses. Right, everything in that parentheses gets raised to the 2nd power. Now you can only do this if what's going on inside the parentheses is either multiplication or division. It doesn't work if there's addition or subtraction inside the parentheses. All right, so but 5x raised to the 2nd power is 5 squared times x squared. And 5 squared is 25, so it's 25x squared. Right? The most common mistake I've seen people make on a problem like that is to just write this as 5x squared and forget that 5 also has to get raised to that 2nd power. Right? Everything within the parentheses gets raised to the 2nd power. All right, and now the last one, which is kind of a diabolical example here, has a lot of stuff going on. Right? We've got 2 expressions being multiplied together. This one's being raised to a -2 power. And we have to get rid of the negative exponents, get rid of the parentheses, and combine the bases together so that there's only one x, one y, and one z. All right, so there's a lot of different ways you can start this. The way I'm going to start this one is, since this second parentheses has that negative exponent, I'm going to start by taking care of that negative exponent. So I'm going to copy down that first parentheses just like it is. X squared z, or sorry, x to the 4z squared over 4y to the 5th. And then since this second parentheses is being raised to a negative exponent, kind of like what we talked about at the top here, if it's a negative exponent, that means the reciprocal. So I'm going to take that second parentheses and flip it all over. 2x to the 3rd y squared over z to the 3rd power. And now when I do that, it's raised to the +2 power. Right? When I flip over that stuff inside the parentheses, that negative turns into a positive. That's using the reciprocal that corresponds to the negative exponent. All right, the next thing I'm going to do here is kind of like what we did in that last example, distribute this 2 into this second parentheses. All right, so I'm going to copy down that first one again just like it is, because I'm not really touching that first parentheses yet. But I will. Don't worry, first parentheses, you're going to get touched pretty soon. That sounded kind of perverted. So I'm going to distribute this 2, so everything in the second parentheses is going to get raised to the 2nd power. So it's going to be 2 squared x to the third squared, y squared squared, which was a little awkward to say, and then z to the third squared. All right, so that's my second parenthesis now, distributing that exponent of 2. And now I need to simplify the stuff in that second parenthesis, actually raising all that stuff to the second power. All right, so that's going to give us, and once again, I copy down that first parenthesis just like it is. We'll get to it pretty soon. And then the second parenthesis, now 2 squared is 4. X to the third squared, that's a power to a power, so I multiply. 3 times 2 is going to give me x to the 6. Y squared to the second power, power to a power, multiply, it's y to the fourth, over z to the third squared, again, power to a power, so multiply. 3 times 2 gives me z to the 6th power. All right, so we're getting a little bit closer. Right, that second parenthesis now, I got rid of that exponent that was outside the parentheses. Now I can actually multiply all this stuff together. All right, so basically what I'm going to do is just kind of run all this stuff together and then see what we end up with. So I'm going to have x to the fourth, z squared, times 4x to the 6th, y to the 4th, all over 4y to the 5th, z to the 6th power. All right, so I got rid of my parentheses, I got rid of my negative exponents, but now I still have, 2 x's, 2 y's, 2 z's involved in my equation, so I have to combine together the x's and the y's and the z's. All right, so to combine the x's, both of the x's are on the top of the fraction here. It's x to the 4th times x to the 6th power. Since I'm multiplying those, I add the exponents. So that's going to give me an x to the 10th power on the top of the fraction. Right, the y's we'll do next, I guess, if we'll go in alphabetical order here. Right, I have a y to the 4th on the top of the fraction and a y to the 5th on the bottom of the fraction. Right, so our y's are being divided here, which means I would have to subtract the exponents. It would be 4 minus 5, which gives me -1. But then that negative exponent tells me I have to flip that down into the bottom of the fraction, and it would be y to the positive 1 power, which if it's a positive 1 power, you don't have to write it, that's just y. All right, so I'm going to end up with a y on the bottom. Now, a quicker way to do that, and the way that I usually do this when I'm looking at these problems, this tells me I have 5 y's on the bottom. This tells me I have 4 y's at the top. Whichever one has the bigger exponent, that's where the y is going to end up. Right? So since the 5 on the bottom is bigger, my y is going to end up on the bottom of the fraction, and 5 is 1 bigger than 4, so my balance is having 1 y on the bottom. All right, so that's how I end up with a y there. And then we can do the same thing with the z's. I have z squared at the top and z to the 6 on the bottom. Right? It's kind of heavier at the bottom. It has that 6 down at the bottom. So I know my z is going to end up down there in the denominator. Now my 2 z's at the top are going to cancel out 2 of the z's at the bottom, which is going to leave me with 4 z's on the bottom of the fraction. All right? 6 minus 2 gives us the 4 z's that end up on the bottom. And then we have the numbers as well, right? We have a 4 at the top of the fraction and a 4 on the bottom, and those are actually just going to cancel out. So that's actually kind of nice. And if I just write this to look a little nicer, just kind of putting that x to the 10th in the middle there. So it's x to the 10th over y, z to the 4th power. And now we have no parentheses, no negative exponents, and we only have 1 of each of our variables. So that was kind of a mess, kind of a big problem to do, but it involves a lot of the rules of exponents. So those are problems that math teachers like to give their students because it tests a lot of different things to make sure you really understand all these laws of exponents and how they all work. So if you just kind of work your way through one little step at a time, look for something that you're able to do that thing, and then look and see what you're left with, find something you can do with that, do that, and just kind of keep on working through. Eventually, if you take your time with it, you'll work it out to the end. All right, so that was going over some of the laws of exponents and some examples of simplifying exponential expressions.